Good morning, class. This is Dr. Karsten, and today we are going to do another day in Lesson 28, and that is from Module 5, Grade 4, Engage New York Math. So today we are going to be working in the problem set. Yesterday I modeled how to do these problems with the homework set, and today I'm going to model how to do it from the problem set. That's where you were doing your work on your own independently. And then I'm going to be pushing out the exit ticket along with some questions, and that's what you're going to be working in today. So, for our lesson today, let's take a look at this problem. So, in this problem it says, the chart to the right shows the distance fourth graders in Miss Smith's class were able to run before stopping for a rest. Create a line plot to display the data in the table. Now, a lot of you were really confused about what a line plot is. You didn't really understand, and it's basically just another way to show information or to show data. And the way that what I likened it to for those of you who met with me in our Google Meet was I said it's really, really similar to having like a bar graph, only instead of coloring in squares, we make X's. So let me show you what I mean by that. So here I have a really quick bar graph, and let's pretend that I had 6 students, and they were asked what color shirt they would prefer. What would they like to have? And here you can see that 2 students chose red, and here you can see that 4 students chose blue. Well, I could have represented this using a line plot. Now, normally we wouldn't use a line plot for this kind of a graph, but we could. So here we go. So instead of doing a bar graph where you can see that I went up for 1 and then I went up for 2 because 2 students had chosen red, I could have put X's and placed an X for each student who chose that color t-shirt. So I'd put an X for one student, and then I'd put an X for another student. And over here, I would have to have 4 X's because 4 students chose blue. So you can see that it kind of looks similar, but it's just different. It's a different way of showing the information, showing the data. Okay, so let's get back to what we are doing today. We are going to show a line plot for this data. So when I'm going to do this, the first thing that I always like to do is I like to decide what are going to be my endpoints. What is my range? And to do that, I need to find the smallest number and I need to find the largest number. And for me, the smallest number just jumps out right here. And that's right here, Jenny. For Jenny, what we're doing, the distance fourth graders in Miss Smith's class were able to run before stopping for a rest. Jenny only got to 5/8, which is just over a half a mile. So now I need to find my largest number here. So the endpoints are going to be the smallest and the largest. So I have 2.5, that's pretty big. 1 3/4 is smaller, 1 1/8 is smaller. 2 5/8 is going to be larger. How do I know that? I know that because 5/8 is larger than 1/2. So if I were comparing those, I would know that. How do I know that? Because half of 8 is 4. So I know that 4/8, and I'll just jot that up here for us. I know 4/8 is equal to 1/2 because 4 is half of 8. So 2 5/8 is going to be larger than 2.5. So let me hold on to that one. If I keep going, nope, 2 2/4, that's equal to 2.5 because 2 is half of 4. 2/8, 4/8, so yeah, this is going to be our largest one. So now what I know is that my range, so my smallest to largest, is going to be from 5/8 to 2 5/8. So how does that help us with our line plot? Well, it's going to let us know what we have to model on the line plot, what our whole number endpoints should be. And in this case, I am going to use whole numbers. And that's what you should be using also when you're doing these today. So if I look at 5/8, I know that the nearest whole number that is smaller than my smallest one is going to be 0. and if I look at 2 and 5/8, I know that my nearest whole numbers, 0, 1, 2, 3, 4, 5, 6, my nearest whole number, let me just tell my computer not to restart right now. My nearest whole number is going to be 3, because 2 and 5/8 is just a little bit more than halfway to 3. So I'm going to put 3 down as my other endpoint. Remember, we want to go a little bit further than the smallest number and the largest number. We don't want them to be our endpoints. So we want to go a little bit smaller than the smallest number, a little bit larger than the largest number. So now I know what I'm going to be putting on my line plot. So let's go ahead and I'm going to work on a piece of paper. Instead of working on the bottom of this one, I really would like to have more space because I happen to know that this is a kind of long line plot with a lot of information close together. So I'm going to go ahead and draw it on a new fresh piece of paper for us. I am going to use a ruler to make my line plot nice and straight. And here we go. And I'm missing my favorite flare. This one's a little wider than I like. I think someone may have borrowed it from my table. Oh, I like that noise. That was kind of cool. So let me just see what can I show on here. I can show the whole thing. Perfect. So I'm going to put my arrows. All right, so for our purposes, I'm going to put 0 way down here. And I'm going to put 3 up here. And again, that is what we decided that was going to be our endpoints for this. Now, before you do anything else, I want you to write a label for what you're going to name this line plot. So in this case, we want to talk about what is this showing? So we're not going to label it. We're not going to put a title for the whole thing yet. We're just going to label what is this showing? Well, this is showing the distance in miles. So let's go ahead and write that. Where did I get that, you might be wondering? Well, I got that right from the table, and I'll show you. Sorry, my voice is a little scratchy still. I'm doing this early in the morning instead of late at night. Okay, and look, distance in miles. That's what we're going to be plotting. That's what we're going to be showing, is how far each of these students ran. So I got it right from the title here. So now we need to label the entire thing. We need to give our line plot a title. Again, I know I mentioned this yesterday. Make sure you do these things before you start graphing, before you start plotting, because as soon as you put all of these and you finish Chandra down here and you put her on the line plot, as soon as you put her X down, you're going to be like, yes, I'm done, and you're going to forget to put a title. So title it now. I think I'm going to title it Distance 4th Graders Ran. So I'm going to write that up top here. Distance 4th Graders Ran. And let me just slide it down so you can see it. Distance 4th Graders Ran. Okay, so now what I need to do is I need to mark off where my other whole numbers are. And maybe what I also would like to do is I would like to show where some of my smaller parts are. So we have 0, we have 3, I need to put in 1 and 2, and that looks like it's about evenly spaced if I were to put them right there and there. So I'm going to go ahead and do that. So that's going to be my 1. And that's going to be my 2. So you can see that we have 0, 1, 2, 3. And I'm going to label those. Now I definitely want to put in my benchmarks, all my halves, but I'm not going to label them yet. So I'm going to put in, this would be where 1.5 is. Let me make my 1 and my 2 really bold. And my 3. And my 0. Okay, so that's 1.5, this would be 2.5, and this would be 1/2. So I've marked my halves in there. If I wanted, I could add in more, but I'm not going to do that yet. All right, so the next thing, well actually, I'm taking a peek at our data, And if I look at our data, what I see is that we have half, we have fourths, we have eighths, we have fourths, eighths. So we have a mix, we have like a half, but other than that, we have a mix of fourths and eighths. So I'm going to give you a little tip. My tip for you is, normally I like to just go straight down with my data, and then I always check off what I've marked, what I've placed on my line plot. But I'm going to make a little suggestion to you, which is start with whichever fractions or mixed numbers have a smaller number in the denominator. So first do all the ones that have halves in it, then go for all the ones that are fourths, and then go for the eighths. But you could just go straight down too. That's fine. Either way is fine, whichever way is going to be easiest for you. So what I'm going to do is, because I know we're going to be having a lot of fourths in there, I'm going to go ahead and mark off my fourths or my quarters. So remember, when there's a 4 in the denominator, it means that you have partitioned off one whole into 4 pieces. So there we go. 1, 2, 3, 4, and I'll partition this off also. 1, 2, 3, 4, and I'll partition this off as well. 1, 2, 3, 4. Okay, so now let's start graphing these. So I'm going to go ahead and, as I mentioned, I'm going to start with anything that has a half in the denominator. So as it turns out, Joe ran 2.5 miles before he needed a break. So let's plot him. So let's find where 2.5 is. So I have 1, 2, and a half. This was our halfway point. So as soon as I'm going to be plotting something there, I'm actually going to go ahead and mark now what this was. So this is at 2.5. And I'm going to go ahead and put an X for Joe. And now I realized I forgot to tell you to do one more thing. We did not put a key in here. We did not let people know what these X's mean. So let's go ahead and do that. So X equals 1 student. And you do need a key to show what it represents. All right, so there we go. So we have Joe on here. And again, you have to check them off once you've done someone. Now we're in luck here. Our next person is fourths. There's no other halves here. So let's go ahead and put Ariana on here. So it's 1 3/4. So let's go ahead and find 1 3/4. So we're going to go 1, and then we're going to go 3/4. 1/4, 2/4, 3/4. So this is going to be 1 3/4, and we have to put an X for Ariana. And then what do we have to do? We have to check her off that we put her on there. So now let's go and see if we have any more fourths. And I'm doing this because right now everything's partitioned into fourths, not eighths. So it'll make my life easier if I do my fourths. So I'm going to do Seisha. Seisha has 2 1/4. So I'm just going to put like a little downward just so I know that I'm doing her. So 2 1/4. So I'm going to go 1, 2, and 1/4. And I'm going to put an X for Seisha. Now, I'm not putting anyone's name on here. You can't figure out who scored what. You're just getting to see how many kids scored at certain points here. So I'm going to write 2 1/4. And then I'm going to go ahead back to Seisha. And I'm going to finish this check mark. And that's my little way to make sure I don't mess up also. So the next person that's in fourths is Tyler. Tyler did 2 2/4. So I'm going to put my little downward part of my check. And we're going to find 2 2/4. 1, 2, 1/4, 2/4. And now what you should be seeing is that 2 2/4 is the same thing as 2.5. And I'm going to put an X for him. So again, 2 2/4 is the same thing as a half. Why is that? Because remember, when your numerator is half of your denominator, 2 is half of 4, that's going to be equal to 1/2. All right, let me finish my check for Tyler. And then I don't have any more fourths. So now I'm going to go back and I'm going to put in my eighths into the graph. Oh, sorry, into the line plot. So right now we have our whole numbers, 0, 1, 2, 3. We have our halves, 1/2, 1.5, 2.5, and we have our fourths, 1/4, 2/4, 3/4, or fourths, 1 1/4, 1 2/4, 1 3/4, 2 1/4, 2 2/4, 2 3/4. So what we want now is to mark off the eighths. So I'm going to go ahead and do that. You know what? Let me grab a whole different color to do that out of my wonderful bag of colors. Let's go for pink. So now I'm going to put in my eighths. So for 8, that means that I need to have each whole, so between 0 and 1 has to have 8, has to be partitioned into 8 pieces. Between 1 and 2 has to be partitioned into 8, and between 2 and 3 into 8. So let me go ahead and do that. And now you can see I have 1, 2, 3, 4, 5, 6, 7, 8. Now let me put the camera light on, that might help. Oh, it was on, never mind. All right, let me do the same thing over here. 1, 2, 3, 4, 5, 6, 7, 8. And here again. 1, 2, 3, 4, 5, 6, 7, 8. So it's all now partitioned into eighths. And now let's start marking these off on here. Okay, so Bobby has 2 and an 8. So I'm going to go and make my downward check. And now I have to find 2 and an 8th. 1, 2, and an 8th. So this is where Bobby falls. I'm going to go ahead and write that this is 2 and an 8th. So again, I'm labeling only where I'm putting my X's. So let's show that we did Bobby. And now we're going on to Morgan. Morgan did 1 and 5/8. So I'm going to go to 1, and then go 1, 2, 3, 4, 5, and I'm going to mark it here. And that's 1 and 5/8. And now you see why I decided to do this like this and make it much longer so we wouldn't be on top of each other here with the X's. All right, so that was my Morgan, right? Yep, 1, 2, 3, 4, 5, 6. So 1 and 5/8 was Morgan. So now we're going to do Jack. Jack is 2 and 5/8. So we're going to have 1, 2, 1, 2, 3, 4, 5/8. 2 and 5/8. And again, it's 2 and 1/8, 2 and 2/8, 2 and 3/8, 2 and 4/8, 2 and 5/8. Now let's put our X. And now we can check them off. All right, now we're down to Jenny. Jenny was just 5/8. She got tired pretty quickly. So let's show 5/8 on here. So we'll start at 0, 1/8, 2/8, 3/8, 4/8, 5/8. Let me give her an X. And let me write what the value is. It's 5/8. And let me go finish checking her off. Next we have Anson. Anson went 2 and 2/8. So let me put my downward check. So 1, 2, 2 and 1/8, 2 and 2/8. And now what you're seeing is that 2 and 1/4 is the same thing as 2 and 1 and 2 and 2/8. So because it was 1/8, 2/8, so 2 and 1/4 is equivalent to 2 and 2/8. Let me finish my check off. Boom. And now we're down to Chandra. And Chandra did 2 and 4/8. Downward check. 1, 2, 2 and 1/8, 2 and 2/8, 2 and 3/8, 2 and 4/8. So now again I'm seeing that 2 1/2 is going to be the same thing as 2 and 4/8. And again, that's because 4 is half of 8 and 1 is half of 2. So we know that those are equivalent. So let me finish my checking off. And now for a few minutes, let's move away from the table altogether and let's take a look at our line plot. So now if you look at this, it's really easy to see, that most kids were right around here in this area. We have 1, 2, 3, 4, 5, 6, 7 students. We're right here between like 2 and 5/8. That's where most kids, that's how far they were able to run before they needed a rest. Then we have these kids who were a little bit, they couldn't go quite as far. And then we have this one kid way down here who got tired really quickly, needed a break really quickly. So it's nice to see all this information. Again, we can't see who did what, but it gives us an idea of how the entire class did. Okay, so we are ready to start looking at the questions that go along with this. Now we are going to be going back and forth between the table and looking at the line plot. And I wanted to tell you one more thing that I think is a good idea. I like to double check that I have everyone marked by counting up how many marks I should have, how many X's. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I like to just go through and make sure I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew, we did it right. All right, so let's jump into these questions. So the first question says, who ran 1 mile farther than Jenny? Now again, on my line plot, I don't know how far Jenny ran. I have to go back to the data. And the data tells me that Jenny ran 5/8 of a mile. Let me jot that down. So what I know is that Jenny went 5/8 of a mile. I want to add a mile onto that. We want to go 1 mile farther. Farther means I'm adding it on. It's bigger. So I'm going to add 1 to that. Well, 5/8 plus 1 is just going to be 1 whole and 5/8. Now, I like to give you guys another way of doing this. Some of you really do so much better when we kind of think of how we add instead of going horizontally, vertically. And just like how we do place values, like if we were adding 15 and 22, we align them and we would have our 1s and our 10s. We're going to do something similar here, where we're going to show our 1s and our fractions. So for this one's a little odd because we're going to have 1, 1, and we're going to have 1 whole number and we're going to have 1 fraction. But you can see, I would have 0 fractions here plus 5/8, and I'd have 1 plus 0 here. So either way, if you do it horizontally or vertically, either is going to be fine for you. So now we have to figure out, though, who ran 1 5/8 mile. So I'm going to go ahead and grab my data because we need a name. We don't just need the number, we need the name. So let's go ahead and look for who ran 1 5/8. And I see that Morgan ran 1 5/8 miles. So I'm looking here and Morgan ran 1 5/8 miles, and I want to go ahead and write that down next to the answer. And there we have Morgan. All right, so next I want to see who ran a mile less than Jack. So first I have to go and see how far did Jack run. So Jack ran 2 5/8 miles. Let me write that down. Let's do a different color just to try and keep this stuff a little organized. So again, Jack ran 2 5/8 miles. And since I want to do 1 mile less, I'm going to subtract 1 from that. So 5/8 is going to stay, and I'm just going to take away 1, or subtract 1 from that 2. And I'm going to end up with 1 5/8. And again, for those of you who do better when we do it vertically, let's show that. So we're doing 2 5/8, and we're subtracting 1 mile from that. So 5/8 minus nothing is going to stay 5/8. 2 minus 1 is going to be 1. Okay, so we have 1 5/8 either way. I just realized that I am not labeling. Oh, well, that's okay because we have to put the names. So see, who ran 1 5/8 miles? Wait, look, it's right there. Morgan ran 1 5/8 miles. It's the same answer. So let's write Morgan again. Okay, next question. The next question says, let me just slide this over for us. 2 students ran exactly 2 1/4 miles. Identify the students. how many quarter miles did each student run? So this is a multi-step problem. First of all, I just want to look at my graph. So it's saying 2¼ and sure enough, here I see 1, 2¼ and I have 2 x's. But who did that? Who ran that distance? So let's go and see if we can find anyone who ran 2¼ miles. So if I look at this, I have 2½, 1¾ I'm skimming down, and here's 2¼ miles. But I only see one of those. So let's first write this person down, and that was Seisha. So Seisha ran 2¼ miles. And I'm going to put Seisha over here. So now here's the thing. I need to figure out who else ran that, but no one else is listed as 2¼ And that's where we have to remember that we can find equivalent fractions. So first of all, I know that I need to have a 2 as my whole number. So I'm going to go ahead and look and see. Here we have 2½. If I convert a half into quarters, let's see what happens with that. So if I take 1/2 and I want to turn that into quarters, we always show what we start with. We're multiplying. 2 times what number gets me to 4? Well, 4 divided by 2 gives me 2. And I'm going to put this up here because whatever I have in my denominator, I also want in my numerator, so we're just multiplying by 1. And 1 times 2 is 2. So now what I know is that since 1/2 is equal to 2/4, I now also know that 2½ would be equal to 2 2/4. Okay, so let's go and see. Well, that is definitely not going to be equivalent to what we're looking for. Remember what we're looking for? Where did I put that? We are looking for 2¼ miles. A half becomes 2/4, so that's not going to work for us. So let's keep looking. Well, 3/4, that looks like it's going to be way too, well, it's not even a 2. Let's find our 2. 2 1/8. 2 1/8. Can I convert 1/8 down to fourths? You know, I can't. And the reason is that my numerator has a 1 in it, right? You know, another thing we could do, instead of going through all this, and I am going to go back and do it mathematically, and this might, though, help us, is I could look at my 8ths, since we don't have any more of those. And I could say, well, remember, these are all 8ths. And so if I'm looking for 2 1/4, let's see how many 8ths that would be. That would be 2 1/8, 2/8. So let's go see if we have anyone that's at 2 2/8. 2 5/8, 2 we did that one, 2 2/4, 2 2/8. Anson's at 2 2/8. So I could just go and write that in, but I do want to show you how that works. So Anson was 2 2/8. So let's see if 2/8 is equivalent to 1/4. Now I'm going smaller, so I'm not multiplying. Instead, I'm dividing by some number. And what we could say is that 8 divided by some number gives me 4, but knowing my fact families, right? I can use a number bond to show this. 8 divided by some number is 4, but also 8 divided by 4 gives me that number, which is 2. Or 4 times 2 is 8. So 2 divided by 2 is just 1. So yeah, 2/8 is equivalent to 1/4, which means that 2 2/8 is equivalent to 2 1/4. Okay, so that's the math way. But again, you could have just looked down here and said, well, 2 1/4 is the same thing as 2 1/8, 2/8. And again, it was Anson who ran that distance before he had to take a break. So let's write and Anson. Now, here's the thing. We only answered one part of it. We only identified the students. We still have another piece to this. It says, how many quarter miles did each student run? So what we need to do is we need to convert 2¼ into all quarters. And how would we do that? How do we convert our 2¼ into all quarters? Well, we have a bunch of ways we can do that. I'm going to grab us a fresh piece of paper. I have one under here still waiting. Make sure we're all lined up again. So, what I know is, remember we want to turn 2¼ into all fourths. What I know is that 4/4 is equal to 1. So what I want to do is I want to decompose this into fourths. So what I could say is that I have 4/4 here, that's 1, and now I can put another 4/4 here. I'm just pulling out ones from this 2, and then I still have my 1/4. So how many fourths do I have altogether? 4, 8, 9. So if I added all these together, I know that 2¼ is equal to 9/4. Remember, all I did was, let's do a tape diagram to make this easier. So I'm going to show, I'm trying to be careful here. I want to make this really accurate. So I'm showing you that this is what is equal to 1 whole. So we have 1 whole, 2 wholes, 2¼ and I'm going to show that like this for you guys. So that's 1, this is 2¼ and now what I can do is I can partition off these into quarters. And now you can see we have 1, 2, 3, 4 quarters in this first whole, then we have another 1, 2, 3, 4 in the second one, and then we have 1 more quarter. So we have 9 quarters. Another way that we could show this mathematically is, remember how we've done this, where we've said it's going to be 4/4, but how many times? 2 times 4/4. We have 4/4 2 times, plus that extra 1/4, and that's equal to our 9/4. So whichever way we decide to do this, we are going to write 9/4. So let's write 9/4. And then what we want to say is we actually want to write that in a real answer. So it says how many quarter miles did each student run? They each ran 9 quarter miles. Okay, let's go on to D. So for D, it says, what is the difference in miles between the longest and the shortest distance run? Whenever we are looking for a difference, we are going to subtract. So first we need to have our longest and our shortest, and those were our endpoints that we already marked off. Uh-oh, where did I put my data? Here's my data. So our longest was 2 5/8, and our shortest was 5/8. So let me write that for us. So we are going to be doing 2 5/8 minus 5/8. And I think that a lot of you are going to be able to say to me, well, 2 5/8 minus 5/8 is just going to leave me that 2. But if you don't just see that easily, then let's go ahead and let's model that the other way that we've been doing it, which is vertically. So I have 2 5/8, and I want to subtract 5/8. So 5/8 minus 5/8, they're the same thing. If I do 2 minus 2, I get 0. Well, if I do 5/8 minus 5/8, I have 0/8. So I'm actually going to write 0/8 for us. And that's just equal to 0. And then 2 minus nothing is 2. So I don't need this. I can just write 2. Excuse me. Which we already did right here in the problem set. We already wrote 2. So what we want to do, though, is now we want to answer this with a sentence. So 2 miles, I'm going to write 2 miles is the distance between the longest and the shortest run. So I always like to write it out, 2, but you could write the number 2. 2 miles, and I'm just pulling it right from here, is the distance, or is the difference, but I'm going to write the distance between the longest and the shortest. Here's where I'm getting distance from. Is the distance run between the longest and shortest run. And shortest run. Okay, let's take a look at the next one. So it says, compare the distances run by Ariana and Morgan using greater than, less than, or equal to. So let's go back to our data, and we have to find Ariana and Morgan. So we have Ariana right here, and Ariana ran 1 3/4 miles. So I'm going to write that. Or 1 3/4. Fourths and quarters are the same. So it's Ariana, and now let's find Morgan. Morgan ran 1 5/8. Now, what's really nice is that I don't have to mathematically convert these. I don't have to change fourths into eighths or eighths into fourths. I can ignore, well, not ignore, but I can kind of hold to the side the ones because they're the same. Remember, when the whole number is the same, we can kind of just leave it to the side and work with the fractions when we have mixed numbers. But I can go back to my graph and I can take a look and see where's 1 3/4 and 1 5/8. So, and here I have them. Here's 1 3/4 and 1 5/8. And what I can see is that 1 3/4 is definitely larger. So what I now know is that Ariana ran farther. I'm going to go ahead and write that. But you know what? I do want to show you how to convert 1 3/4 into 1 5/8. And I'm going to do that. I keep going on to this other paper because I want to have more room to work. You definitely can work in the space provided. So if I want to turn 1 3/4 into a number that's going to have 1 and something eighths, what I can do is I can focus on my 3/4 and figure out how do I change that into eighths. Oh, it's getting brighter in here. So 3/4, I want to decompose it into eighths. I always write what I'm starting with, and now I have to say to myself, 4 times what number gives me 8, or another way of doing that is 8 divided by 4 gives me that number, and you should get 2. Whatever you do in your denominator, you have to do in your numerator. So we have 4 times 2 is 8, and 3 times 2 is 6. So now what I know is that 3/4 is equivalent to 6/8. So 1 3/4 is equivalent to 1 6/8. So clearly then, I can now see that 1 6/8 is larger than 1 5/8 if I'm looking right here, right? So because 1 3/4 is 1 6/8, and having 6/8 is larger than having 5/8. The denominators are the same, so I look to see who has more pieces, who has more of this sized pieces. And 6/8 is definitely greater than 5/8, so 1 6/8 is going to be larger than 1 5/8. And you can jot that on here. You can say that 1 3/4 is equal to 1 6/8, and that shows how you did this. And so now we know that 6/8 again was greater than 5/8. So let's write here, Ariana ran farther. Don't know if she ran faster. She may have walked the whole thing. Or she may have ran really fast. Okay, next problem. Miss Smith ran twice as far as Jenny. How far did Miss Smith run? Write her distance as a mixed number. So first we have to go and figure out how far Jenny ran. And Jenny where is she? Jenny is the one who ran only 5/8 of a mile. So what I want to do, let's switch back to our purple. So Jenny ran 5/8 of a mile. And what we want to do then is say, well, Miss Smith ran twice as far, right? Because they tell us she ran twice as far. Twice as far means times 2, or you could add it twice. So you have two choices. You can do 5/8 plus 5/8, or we can do 5/8 times 2, or 2 times 5/8, which is what we normally have done. So I'm going to go ahead and do that and put it, that's how we tend to write things. So 2 times 5/8. So it's 5/8 2 times. Now, when we're multiplying by a whole number, remember that what we can do is we can say, well, that would be 2 over 1. The reason we can do that is, remember, the denominator tells us how many pieces one whole has been partitioned or cut up into. Well, in the case of whole numbers, it hasn't been cut up at all. It is still one whole piece. And for multiplication, we do not need the same denominator. For multiplication and division, we just go straight across. So 2 times 5 is 10, and 1 times 8 is 8. But again, it asked us to put it as a mixed number, not as a fraction. So now we have to take that 10/8 and we have to turn it into a mixed number. So I'm going to do that over here where I have a little bit more room. I'm going to write 10/8. And what I know is that, I'm going to jot what I know over here just because I'm trying to keep things a little neat in here. I know that 8/8 is equal to 1. Why am I dealing with 8s? Because 8 is in my denominator. So 8/8 is equal to 1, so I want to pull out any whole numbers I can. So I'm going to pull out 8/8 because 8/8 is one whole. So I had 10 pieces that are 8ths. So I had 10 pieces, I put 8 over there, which means that I have 2 over here because 8 plus 2 is 10, or 10 minus 8 is 2. What size are those pieces? They're 8ths because all of these are going to be 8ths. So this 8/8 is equivalent to 1. So I'm going to write that. And 2/8 would just stay 2/8. Unless you want to compose it. But we're not going to get all crazy right now. So we know that Miss Smith ran 1 2/8 miles. Miss Smith ran 1 2/8 miles. Okay, now you see why I'm kind of trying to keep things as neat as possible. We have a lot of information going on here. And I feel like this is going to be a really long video, and I apologize for that. It's just a lot of questions, but I do want you guys to see how to work through these. All right, last question that we're doing. We're not doing this one. We're just going to do this one. Mr. Reynolds ran 1 3/10 miles. We want to compare that distance as using greater than, less than, or equal to compare the distance Mr. Reynolds ran to the distance that Ms. Smith ran. Who ran farther? So let's go ahead and let's jot down those two numbers so that we can show it. So Mr. Reynolds ran, and I want to have room, so that's why I'm working over here, 1 3/10 miles. And Miss Smith, we have here, ran 1 2/8 miles. And we do not have a common denominator to compare these two. So we are going to have to get a common denominator. They are not related, so we are definitely going to have to figure this one out. So here's a nice clean piece of paper for us to work with. So I want to compare, I'm going to jot it down here again. We have 1 3/8, and we have 1 2/8. Sorry, that's a mess. Let's flip this over. So I'm sorry about that. We have 1 3/10, and we have 1 2/8, and we're comparing those two numbers. So let me give us some clean workspace here. Okay, so I can't compare my tenths and my eighths because my denominators are different, and my numerators are different also. So what I'm going to want to do is I'm going to want to change these so that they have the same denominator. Now I'm going to hold my 1s to the side because they're the same number, and I'm just going to work on converting those fractions. So I need to figure out, is 3/10 larger or is 2/8 larger? And the way we do that is we are going to take 3/10, and we show what we're starting with. And remember what we do? We take the fraction and we multiply it by the other fraction's denominator. In this case, the other fraction's denominator is 8. Whatever I do in the denominator, I have to do in the numerator. And 3 times 8 is 24, and 10 times 8 is 80. So now what I need to do is I need to convert this one as well. So I'm going to do 2/8, and I want to convert that. And now I know I'm turning it into 80ths, but I'm not going to write that yet. I don't want to give it away yet. So again, if I want to convert this fraction, I'm going to multiply it times the other fraction's denominator, which is 10. Whatever I do in the denominator, I do in the numerator. And 2 times 10 is 20, and 8 times 10 is 80. So now I can compare 24/80ths and 20/80ths. The denominator is the same, so just look to see how many pieces you have for each, because the sizes are the same. They're both 80ths. 24 is more than 20. So I know this one's larger, so I know this one is larger, so I know this one is larger. So 24/80ths is equivalent to 3/10, so those are both the larger one. He's larger than this, which means that 1 and 3/10 is going to be larger than 1 and 2/8. So we really should show how we did this here. So let's first show it. And then I'm going to really quickly kind of squeeze it in here. So I want to show how I converted, and that 3/10 was equal to 3. I'm just quick going to write it down because we already did it. So I'm just copying it over here. And then the same thing here. And you should be showing this kind of work because it explains to anyone who looks at this, like your teacher or someone scoring a test, how you got this, because we do like to see work shown. And so now what I can see is that this one was larger, right? And I like to circle it. Okay, so we should write here that 1 and 3/10 was greater than 1 2/8, so we should write Mr. Reynolds ran farther. Mr. Reynolds ran farther. Okay, so that's it, class. So just really quickly, I want to remind you that when you are doing one of these line plots, you have to make sure to first figure out what your endpoints are, mark them off. Don't forget to label what you're showing. In this case, it was distance in miles. Don't forget to have a key. What does each X represent? And make sure that you title your line plot. Those are things that should happen whenever you're working on things like this, like graphs or any sort of a visual display of data. And again, line plots are really useful for that. They do not show us what each person did, but they give us an idea of our entire data. And you can easily see where most people ran, what was the most common, or the mode, what are our endpoints. It's a nice, easy visual display, and it really shows you that these are individuals running these distances. All right, so that's it for today. Class, I will see you in our Google Classroom. Have a great day.